Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to discuss isomorphisms. In particular, we're going to demonstrate physically what an isomorphism of two graphs means. Here I've constructed a graph using pipe cleaners and some toys, and the purple toys represent the vertices of the graph, and the pipe cleaners are the edges. I've labeled the vertices A, which is connected to vertex B, which is connected to vertex C, and vertex C is connected to vertex D, which is connected back to vertex A. We also have a vertex labeled E, which is connected to both vertex B and vertex D. Notice that vertex B has degree 3. Also, vertex D has degree 3. Degree means the number of edges that connect to that given vertex. Our graph is connected. It has 5 vertices, 2 of degree 3 and 3 of degree 2. It can only be isomorphic to another graph with the same characteristics. We would like to see if we can create an isomorphism between this graph and another graph. N, M, O, P, and Q are the vertices on the other graph. And this is going to mean rearranging our given graph in such a way that the degrees correspond. I might try crossing C over the edge between E and B. C has degree 2, so I like that C might correspond to O or P. If C corresponds to O, then perhaps we could cross E over and make it correspond to P, because P and E both have degree 2 as well. This would mean that D would correspond to Q. And if we check, we see that D does have degree 3, just like Q. Q would then connect to N, and D would connect to A, and N and A both have degree 2. So this is looking good. It looks a little awkward because the one edge is kind of long, but in graph theory, the length of the edge doesn't matter. So I'm just going to squish that together, and here we have a shape that looks just like the NMOPQ shape. And the really important thing is that we've achieved this without untying any of the edges from the vertices. So we've created an isomorphism where A and N match up, B with M, C with O, D with Q, and E with P. So it turns out that although these two shapes look quite a bit different, we were able to rearrange them and create an isomorphism. In graph theory terms, these are equivalent shapes.